Right, so now we're going to get into some nomenclature for alkenes. And we're going to start by looking back at that example that we ended the previous video with. So what would we do with its naming so that we'd know which isomer of this molecule we were talking about? Well, if you recall the Ingold-Prelog rules that we use for assigning R and S, we're going to use those here for alkenes as well. It's a little bit different for alkenes though. What we do is we look at each carbon of the alkene individually. So each carbon of an alkene, it has two other groups on it other than the alkene itself. The alkene itself is of course two bonds, which means that that carbon has to have two other bonds. So in the case of this first carbon, the one on the left that I've highlighted in yellow, the substituents are iodine and fluorine. And as we did with R and S, we use Ingold-Prelog rules to assign priority between those two groups. So what gets higher priority here? Well, we know that iodine is higher atomic number than fluorine, so iodine is 1 and fluorine is 2. Then we go to the other carbon of the alkene and we look at the two groups that it's attached to. In this case, those are bromine and chlorine. Which one of those is higher priority? Bromine is higher atomic number than chlorine, so we have 1 and 2 like this. So what now is the relationship between the higher priority substituents? Are they cis or trans to each other? So if the higher priority are cis, then we call it E from the German word for same. If the higher priority were trans, then we use Z, which comes from the German word for together. So in the case of the alkene we've drawn here, the higher priority substituents are on the same side. They're cis to each other, so this would be the Z isomer. What that means is that the other isomer of it, this one here, higher priority iodine and chlorine, are trans to each other, and that would mean that this was the E isomer. Alright, so that's our first piece of alkene nomenclature. The other piece of alkene nomenclature is the alkene itself. Now you may recall at the beginning of nomenclature when we did alkanes, I said that alkane nomenclature sort of set the ground rules for all of our other functional groups. So on the left we have an alkane, being one with 4 carbons. This is butane. On the right we have an alkene with 4 carbons. Well, what changes between the names of the functional groups? Alkane, alkene. So could it be as simple as butane and butene? Well, other than discussing the position of the alkene, yes, it is. So a 5-carbon molecule with an alkene would be pentene, 6 carbons, hexene, and so on. Now there is another piece that we need to address, and that's that we need to know where the alkene is. And in fact, for butene, there's actually 3 different butene isomers that are just 4 carbon molecules. We haven't started dealing with substituents yet. So we need to number them, and we need a number in our name to indicate where the alkene is. Now, when we're numbering the parent chain, we do it such that the double bond is closest to the end. Pi bonds, whether we're talking about alkenes, alkynes, anything that has a pi bond gets priority over substituents. So we can number it starting at this end. That puts our alkene on the first carbon. Impossible to put it any lower, so we don't need to look at the other direction. And so this is 1 butene. We only need the first number for the alkene because we know if the alkene starts on carbon 1, it has to end on carbon 2. Now sometimes you'll see this named in a slightly different way, and that's but1-ene. What's the difference? Well, in this case there is no difference, and you could use either name, and either name would be acceptable. But when we start getting to more complicated molecules, molecules where we might have 2 or 3 or 4 functional groups within the parent name, in that case you have to do it this way. Because if you had 2 functional groups in your parent name and then just 2 numbers out front, you would have no way of knowing which number corresponds to which functional group. But if you put them internal, then you know specifically because the 1 here comes directly before the alkene. So you know that 1 corresponds to the alkene. So how would we name these other 2? Well, these other 2, it's not going to matter which direction we number them from, because the alkene is exactly in the middle. So this is 2-butene. But we also need our E and Z. So this first one, are the higher priority group on the same side, or are they on opposite sides? We can see here that they are on opposite sides. And so that makes this molecule E. So just like with R and S, E and Z go out in front of the name. If we have more than one of them, then we need numbers in front of each E and Z so that we know which alkene they correspond to. Just the same way we did with R and S, that we would put a number in front of each R and S if there was more than one. Now, if our molecule has both E and Z and R and S, then they go all together out in front of the name in the same set of parentheses, and we put them in numerical order. And we will see examples of like that in the not too distant future. So this molecule here on the bottom, the higher priority group's on the same side. So this is Z2-butene. What if we have more than one alkene? So here is, of course, our parent chain. Total of 7 carbons, so we're looking at a derivative of heptane. Now if we number this, we can number this left to right, which I'm doing here in green. Or we'll use purple to go from right to left. So if we go with our green numbers, our first alkene is on carbon 2. Whereas if we use the purple numbers, the first alkene doesn't show up until carbon 3. So that means the green numbers are what we want. The alkenes are at carbon start at 2, and the second one starts at 4. So this would be 2,4, but we can't say heptene here because there's 2 alkenes. How do we indicate 2 of a functional group? The same way we indicate 2 of anything else. So 2,4-heptadiene. Are we done? No, we need to indicate the stereochemistry. And so the way I've drawn these, both of these are E. So this would be 2E, 4E, 2,4-heptadiene. We haven't talked about substituents at all. And the reason we haven't is substituents are named exactly the same way that they were when we do alkanes. They get a number assigned to them based on where they are on the parent chain, and then they get put in alphabetical order. So at this point, you should get out in-class exercise number 19, which will give you some practice dealing with alkene nomenclature.